Hey, hello, good evening. Welcome to the second session. We will see further problems from question number 7 in the series. So, a small correction before I start this video. This last session from 1 to 6 problem, question number 3. While solving this thing, uh, in this step, 5 minus 4, I wrote yesterday minus 1. This is actually plus 1. So, if I write down here plus 1, that means this part won't be there at all. So, the answer would be plus 50. Okay, plus 50. So, let's go and see the next problem. Question number 7. So this is asking us to find the value of r is equal to 0 to 10. This minus 1 power r, 4 power. So r is equal to 0 to 10 minus 1 to the power r, 4 to the power 10 minus r, and then 30 cr into 30 minus r c 10 minus r. This is given to be 30 ck into 3 to the power k. So this implies if I consider only this part, so sigma r is equal to 0 to 10 minus 1 to the power, I'll keep it here, 4 to the power 10 minus r. 30 cr could be written as 30 factorial, r factorial, 30 minus r factorial, into, again, this guy will be 30 minus r factorial, or 10 minus r factorial, and then 30 minus 10 will be 20 factorial. Now, if I take all these constants out of this summation, so I'll be having basically 30 factorial and then 20 factorial. And then this will be simply r equal to 0 to 10 minus 1 r 4 power 10 minus r. And this part gets cancelled. So I'm left with 10 factorial and 10 minus r factorial. This looks incomplete without r factorial. 10, sorry, this is not 10 factorial, that's r factorial. This is r factorial, this is 10 minus r factorial. So now I'll multiply and divide by 10 factorial. So just to give the complete look. So now this gives me basically this is 30 C 10 I can write down, or I can write down 30 C 20 depending upon the interest. But then at the end we have to modify. We have to see that this K and this K both should be same. So we'll write down here 30 C 10 or 30 C 20 depending upon the situation. Let's go for this. This would be simply what? R is equal to 0 to 10 minus 1 power r. This is 4 to the power 10 minus r, and this could be written as 10 CR. Now, if I see this further, then this thing turns out to be 30 C 10. And then this is nothing but the binomial expansion of 4 minus 1 to the power 10. So in this case, I'll be having here 30 C 10 into 3 to the power 10. Now, since these both are same, so my K would be 10. So K is 10. Now I'll go for the second one. So second one is what? Simply sigma r is equal to 0 to 20, 30 CR, 20 CR. So 30 CR into 20 CR. This could be written as sigma r is equal to 0 to 20, 30 CR into 20 C. We'll write 20 minus R better. Now here I can apply Vandermonde identity. So this will be 30 plus 20, which is 50 C. This will be 20. Or it could be written as 50 C 30. Both are allowed. So here what is required? Okay, we want NC20. That means N will be simply 50. So N is equal to 50 in either of the case. So the identity which I have used is the Vandermonde identity. You might be knowing it by a different name or something. So it is talking about NC0 MCR plus NC1 MCR minus 1 plus NC2 MCR minus 2, and so on up to NCR NC0 is equal to M plus NCR. This I have used here for this thing. So I have N is equal to 50 and K is equal to 10. So answer would be 60. So answer would be 60. Let us see the next problem. Okay. we have here an integral 0 to pi by 2 cos square of pi by 2 times cos square of pi by 2 times cos square of x. So of course, I'll be consider this thing as 0 to pi by 2. Then this would be cos square of pi by 2 times cos square of pi by 2 times cos square of x. There are two brackets only. So now by looking at this thing, the only thing that strikes us is the king property. So I'll be using the kings. So pi by 2 and then cos square of this will be pi by 2. This will be cos square of pi by 2 minus x. I'll be using this property. So this would give me 0 to pi by 2 and then simply cos square of this is pi by 2 here and then cos square of this will be pi by 2. Cos square 90 minus x can be written as sine square x and then dx. Now 0 to pi by 2, then cos square of pi by 2 and then cos square of pi by 2. The sine square I'll write down 1 minus cos square of x. So this would give me 0 to pi by 2 cos square of pi by 2 and then cos square of this is pi by 2 minus pi by 2 cos square, so which is cos square of 90 minus theta can be written as sine square. So I'll be writing here sine square of pi by 2 cos square x. Now after this part, we will simplify because our goal is we have here cos square pi by 2 cos square x and pi by 2 cos square x. Nested inside here. That means my goal should be to simplify this further instead of breaking it down further from inside. So now my target would be to get rid of this sine square. So again, I'll be writing this sine square as in the next stage. 0 to pi over 2, we have cos square of pi by 2, and then now this sine square I'll be writing 1 minus cos square of. So 1 minus cos square of again pi by 2 times cos square x. Pi by 2 times cos square x dx. And this is nothing but again you see cos square of pi by 2 minus, so that means this should be written as sine square of again pi by 2 into cos square of pi by 2 into cos square of x dx. Now this is also I. So if we look at this, then what do we have here? Is cos square of some theta here, and the same theta I have here also. So now if I add 1 and 2, so if I add this equation, this is I and this one. So adding 1 and 2, this would give me simply 2i is equal to 0 to pi by 2, and then sine square plus cos square will be 1. So I will be simply pi by 2 into 2, which is pi by 4. So the answer would be pi by 4. Let's see the next one. We now have a parabola here. A parabola touches the bisectors of the angle obtained by these lines. So I have my line L1, which is x plus 2y plus 3 is equal to 0. And my second line L2 is 2x plus y plus 3 is equal to 0. Now I have the bisectors of this line. So let's say the bisectors be B1 and B2. These are my bisectors. These bisectors are touching this parabola at the point 1 and 1 and 0, minus 2. Then which of the following is correct? All right, let's go and find the bisectors first. So for the obtuse angle bisector, obtuse angle bisector. But ultimately, since we have to find both the bisectors, so there is no point of acute and obtuse. We'll directly go ahead to find out the bisectors. So it will be given by x plus 2y plus 3 over root 5 will be equal to plus minus, and then we have 2x plus y plus 3 upon root 5. So this and this gets cancelled. So one of the bisector will be x plus 2y plus 3 is equal to 2x plus y plus 3. And the other one is x plus 2y plus 3 is equal to minus 2x minus y minus 3. So this 3 and 3 gets cancelled. 2x will go to that side. So this becomes x is equal to y. And here I get 3x plus 3y plus 6 is equal to 0. Means I get x plus y plus 2 is equal to 0. So these are my bisectors. Now we just consider the diagram here. So suppose there is a parabola like this. And I have the bisectors. So bisectors are like this. And it touches the parabola at 2 points. So you can imagine the diagram to be like this. That's it. So this is my point now. So my line x is equal to y, and this line is x plus y plus 2 is equal to 0. So if I consider that point of intersection, so this would be, I can plug in x is equal to y directly here, so y will be minus 1. That means minus 1 comma minus 1 is the point of intersection. So I'll call this point of intersection, say, some r better. And this is my point B, and it touches the point 1 comma 1. So 1 comma 1 will lie on this line. So I'll write down P as 1 comma 1, and point Q will be my 0 comma minus 2. So 0 comma minus 2 will lie on this line. Now, and since these bisectors are of course perpendicular, okay, so these bisectors are nothing but tangents and they are perpendicular. So perpendicular tangents intersect at the directrix. That means minus 1 comma minus 1 lies on the directrix. So this point will be on the directrix. So that means PQ must be this implies PQ must be the end point of focal chord. PQ must be the end point of focal chord. Why? Because my tangents are perpendicular. So perpendicular tangents are drawn to the endpoints of focal chord. So this chord must be the focal chord. And then we have seen the another property of the focal chord in my parabola class. If I consider a circle, okay, a circle drawn considering the focal chord as diameter, so the result is circle drawn considering focal chord as diameter. A circle drawn considering focal chord as diameter. As diameter touches the directrix. This is one. Second result we'll be using. So if I have a circle which if I consider the focal chord, then I have a circle and it will touch the directrix. So if it is touching the directrix, then we know the point of intersection is minus 1 comma minus 1. That means this must lie on the directrix. So if it is lying on the directrix, then of course the equation of directrix is nothing but the tangent at minus 1 comma minus 2. So if my circle is touching the directrix at this point, that means at minus 1 comma minus 1 I should be getting the tangent, and tangent is nothing but the directrix. So I'll find out the equation of this circle which is passing through the whose endpoints of the diameter are 1 comma 1 and 0 comma minus 2. And then also we can say from one more thing here, that if I have a parabola, so if I have a parabola and say this is the tangent at the vertex and this is the directrix. So if I have a tangent at this point, and this is the focus, yes. So from this point of contact P to the point where it meets the directrix T, this will subtend a right angle at the focus. So this result also will that a point from the point of contact to the point where it subtends the right where it meets the directrix. This both will subtend right angle at the focus. That means if I see it here, then this is also 90 degree. So this is 90 degree right here. That means this PQ is perpendicular to, say, this is S. So this implies PQ is perpendicular to SR. So my PQ is perpendicular to SR. This is my result 2. Result 2 I'll be writing the portion from the point of the contact, portion of tangent basically, huh? Portion of tangent from the point of contact to the point where it meets the directrix, subtends a right angle at the focus. Subtends a right angle at the focus. Now, if I use this thing, then I just have to find out the equation of the circle first. So the equation of circle. So let the equation of circle be. X minus x1, x minus x2 plus y minus y1 into y minus y2 is equal to 0. This is the diametric form of circle. Now I'll just multiply. So x square minus x plus y square minus 2y minus y plus y minus 2 is equal to 0. So therefore, equation of tangent at this point. So equation of tangent at -1, -1 is the directrix. By the result 1. So now let's find out the equation of tangent at the point -1, -1. So I'll use this one, x1 plus y1 minus 1 over 2 times x minus 1 plus 1 over 2 times y minus 1 and minus 2 is equal to 0. So let's multiply this here. So minus 2x minus 2y minus x plus 1 plus y minus 1 minus 4 equal to 0. So x minus 3x and then y minus y is minus 5. Then this one and this one gets cancelled, and then we have minus 4 is equal to 0. So this gives me 3x plus y plus 4 is equal to 0. This is the directrix. So 3x plus y plus 4 is the directrix. So the equation of directrix is 3x plus y plus 4 is equal to 0. This marks my option C. Now I need to find out the focus of parabola and the length of lattice vector. So if we want to find the focus of focus, then what we will do, we'll use this concept. We have the equation of this directrix, and then from I have here this R and this S. So RS is perpendicular to PQ. So let's find the equation of PQ. So since RS is perpendicular to PQ, this is 1, 1 here, and this is 0, -2 here. So this was my PQ, and RS is here, like this. So R point is basically -1, -1. That means I just now need the equation of line, which is perpendicular to PQ and passes through R. So we simply need the equation of PQ. So what is the slope of PQ, by the way? y2 minus y1. So 3 upon x2 minus x1 is 1. So therefore, MRS would be -1 y3. So equation of RS will be equal to y minus y1 is equal to m into x minus x1. So this gives me 3y plus 3 is equal to minus x minus 1, which is x plus 3y plus 4 is equal to 0. So this is my RS. And also the equation of PQ. And equation of PQ we can find out. So slope we have, plugging in the point. So y minus y1 is equal to m into x minus x1. So we have here y plus 2 is equal to 3x. That is 3x minus y minus 2 is equal to 0. So this is my PQ. And this is my RS. So if I solve our PQ and RS, then I get my focus. So let us solve them. So I'll multiply this equation directly by 3. So I get 3x plus 9y plus 12 is equal to 0. I multiply this equation by 3. So now I'll subtract. So this gives me minus 10y minus 14 is equal to 0. So y is equal to 14 by minus 10, which is 7 by minus 5. This is y. Now plug in here. So this gives me 3x is equal to y, which is minus 7 by 5 plus 2. I'll transfer this to that side. So 3x would be equal to 5. 10 minus 7 is 3 over 5. So x will be 1 over 5. So 1 over 5 and y is minus 7 by 5. So 1 over 5 and minus 7 by 5 is option A. That means A is also correct. So eventually B is wrong. Now we need to find the length of lattice rectum. So for the length of lattice rectum, so suppose this is my focus. Focus is 1 by 5 minus 7 by 5. 1 by 5 minus 7 by 5. And the directrix is 3x plus y plus 4 is equal to 0. This is the directrix. And now we have to find the length of lattice rectum. So we know that from focus to directrix distance, if I have a standard parabola, so this is the focus, this is the directrix, and these two distances are basically 2a. So length of lattice rectum is 2 into 2a. So I'll find out 2a from here. So 2a will be perpendicular distance of this point from this line. So which is modulus of 3 by 5 minus 7 by 5 plus 4 upon square root of 10, which is 9 plus 1. So this is my 2a. That means I can get here 3 minus 7 is minus 4 by 5. So this gives me minus 4 by 5 plus 4 on root of 10, which is 5 into 4. 20 minus 4 is 16 by 5 root of 10. So therefore, length of lattice rectum will be 2 times 2a, which is 32 by 5 times root of 10. So 32 times 5 by root 10. And this is given to be 16 root 5. That means D is incorrect. So that means only A and C are correct. Let's go for the next one. So we have a chord AC of parabola y square equal to 4x subtends a right angle at points P and D on the parabola. If A, B, C, D are represented by this, then all these things we need. So that means if we see the picture of this thing, how it would look like. So I have a parabola here. And now we have chord AC. So it is like this. I have a chord AC here. And this subtends a right angle at B and D. So you can imagine it this way. So this is my point B. And this is perpendicular here. Then there is another point here. It's perpendicular here. So it's like this basically. So I have the chord AC and it is subtending a right angle at B and D on the parabola. So A is basically what? T1. That means A will be given by, we'll take the parametric point. So we have y square is equal to 4x. So any point will look like AT square. A is 1. So T1 square comma 2A T. That's how any point on the parabola will look like. So if I have here A is 1. So my any point here will look like T square comma 2T. So A will be T1 square comma 2T1. And C is given by 3. So this will be T1, T3 square comma 2T3. T is fourth one. So that is T4 square comma 2T4. And B will be T2 square comma 2T2. So I have the 4 points. Now what are we saying that this is subtending a right angle? That means I see that AB is perpendicular to BC. So this is perpendicular, then product slope of MAB, slope is MAB, I'll denote, and slope of BC must be minus 1. So the slopes, the product of the slopes is minus 1. So let's find the slopes. So MAB is this, which gives me 2 times T1 minus T2 on T1 square minus T2 square. That can be written as T1 minus T2 into T1 plus T2. So this one I have. And then next one is again MBC is 2 times DC is this. So T3 and T2. So T2 minus T3 on, again, T2 minus T3 into T2 plus T3. This will be equal to minus. So this gets cancelled, this gets cancelled. So from here I get T1 plus T2 into T2 plus T3 is equal to minus 4 for this one. Now AB is perpendicular to BC. The same way I can write down AD is perpendicular to DC. So AD is perpendicular to DC. So if AD is perpendicular to DC, that means the product of their slopes will be again minus 1. So AD slope is AD, that means T1 and T4. So 2 times T1 minus T4 upon T1 minus T4 into T1 plus T4. This into 2 times DC. DC so will be 3 and 4. So T3 minus T4 over T3 minus T4 into T3 plus T4 is equal to minus 1. So this gets cancelled, this gets cancelled. So I get another equation which is T1 plus T4, T3 plus T4. So T1 plus T4 into T3 plus T4 is equal to minus 1. This is my equation 2. So I'll think of, now we have no other information. That means we need to complete the problem using this much. So what we can do here is, get this equation, T1 plus T2, T2 plus T3. So we have T1 plus T2 into T2 plus T3 is again minus 4 given. Plus T2, T2 plus T3 is minus 4. So let's multiply this better. This one will give me T4 square, then plus T4 into T3 plus T4. Bad idea. T1, T3, T1, T4. Okay. T1 into T3 I have, then T1 into T4. So this will be T1 and then T3. This plus T1, T3, then plus 4 is equal to 0. And I'll be having here T2 square plus T2 times, again, T1 plus T3 plus T1 into T3 plus 4 is equal to 0. So if I ignore T4 and T2 and write down, let's say I have Z square plus Z into T1 plus T3. This is not a complex number, just a variable. Plus T1, T3 plus 4 is equal to 0. So if we watch it carefully, then T4 and T2 are the roots of this equation. Or the equation. This equation, suppose this is the equation, it's satisfied by T4 and T2. That means T4 and T2 are the roots. So if they're the roots, then sum of the roots we can find out. So T4 plus T2 will be sum of root, which is minus of T1 plus T3. That's what we have. So from here, we get T4 plus T2 by T1 plus T3 is equal to minus 1. So that means this value T2 plus T4 upon T1 plus T3, this is nothing but minus 1. So I'll get the modulus, which is 1. And if you see here T2, T4, which means it's the product. So from here, we can also write down T2 into T4 will be equal to, the product is T1, T3 plus 4, which means T2 into T4 minus T1 into T3 is equal to 4. So this also we have got. Second answer would be 4. Now we need the minimum value of T1 minus T3. So since if I consider this one, this equation, so T2, T4 are real. So they are real. That means B, the discriminant here should be what? So B square minus 4AC. B square minus 4AC should be positive. So T1 plus T2 square. Okay. Also, If I want minimum value for T1 minus T2, then I'll consider the square, which can be written as T1 plus T2 square minus 4 times T1 T2. It's 3 by now. Required 1 minute. Okay, T1 minus T3 T2. So let's find T1 minus T3 then. If I consider the T1 minus T3 square, so T1 minus T3 square can be written as T1 plus T3 square minus 4 times T1 into T3. Now, T2, T4 are real, so B square. B square is what? T1 plus T3. So T1 plus T3 square is B square minus 4 times A into C is T1, T3 plus 4. This must be greater or equal to 0. That means T1 plus T3 the whole square minus 4 times T1, T3 minus 16 must be more than 0. This is nothing but my mod of T1 minus T3 square should be greater or equal to 16. Which implies mod of T1 minus T3 should be greater than or equal to 4. So the minimum value is, so the answer here would be 4. Coming to the next question. So here is the new guy. So we have a differentiable function at x is equal to 0 satisfies this in the value of this limit we have to find out. So this limit is on the sigma, and then limit x tends to 0, we have 1 over x, then sigma n is equal to 1 to infinity. We have minus 1 power n into f of x by n. So let's go ahead, and first thing that we will do is get rid of this limit here. So I can write down the sigma here. N is equal to 1 to infinity minus 1 power n outside here. And this would give me limit x tends to 0. So we have here f of x by n minus f of 0 is equal to 0. We can write down because our goal should be to bring the definition into the picture. So limit n is equal to 1 to infinity minus 1 power n. Then we have limit x tends to 0. This is f of x by n minus f of 0. Oh, well, this is x. So I'll write down x by n here. And then this is x by n and then n here. So basically, this portion will be simply f dash of 0 because of the definition. So we have here sigma n is equal to 1 to infinity minus 1 power n into 1 by n. Now, if we need to find out the sequence, sum of this series basically n equal to 1 to infinity minus 1 power n to 1 by n. So minus 1 power n into 1 by n sum I want from 1 to infinity. So for this, we'll take help from the logarithmic series, and we have here log of 1 plus x is equal to, so x minus, and so minus 1 to the power n, we can even get it from GP also. So we have 1 minus x plus x square minus x cubed plus x to the power 4 and so on will be 1 over 1 plus x. Now I'll simply integrate this. So x minus x square by 2 plus x cubed by 3 minus x to the power 4 by 4 plus x to the power 5 by 5 and so on is equal to ln of 1 plus x. So I can write down ln of 1 plus x is equal to, this would be x minus x square by 2 and then plus x cubed by 3 minus x to the power 4 by 4 and so on. So I just need to see some value that I can plug in here to get this. So if I open with 1, so I get here minus 1 basically. Minus 1 to the power n to 1%. So yeah. Minus 1 over 1 plus this is 2. So 1 over 2 I get. 1 over 2 I want. So for 1 over 2, we need to see what do we get. So for this, we can think of getting Yeah, we'll rather plug in x is equal to minus half. I'll plug in x is equal to minus half because we need to get this here. So if I plug in x is equal to minus half, no, but this is not giving me the exact thing. Wait a minute. We can plug in x is equal to 1 first because we have minus 1 power n over n. So if I set x is equal to 1, then in this case I get ln2 is equal to, this will be 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 and so on. But I need to get plus 1 by 2, so I'll multiply by minus. So minus ln2 is nothing but ln half is equal to minus 1 plus 1 by 2 minus 1 by 3 plus 1 by 4 minus 1 by 5 and so on. So answer would be ln of half. Coming to the next question. So then we have an ellipse x square over 45 plus y square over 12 equal to 1, and tangents are drawn at points this intersecting the major axis at all these points. Then the value of these triangles, whatever they are, let's see. So imagine that I have an ellipse here. And let us say this is my some point where the tangent is being drawn. Somewhat like this. Then this means the axis, major axis at, I'll call it beta ti. And this is my point pi. This right here is s, and this is s dash. So we need to see pj tjs. So I'll better say pj, so I've got the I. Great. So this will be pj and this will be tj. So pj tjs will be this triangle basically right here. So pj tjs is this triangle. So if I want the area of this triangle, then of course pj tjs is equal to tj I have. Let's find out the area of this triangle and see what do we get. Then we also have pj tjs dash. Pj tjs dash means this triangle basically. So I'll draw it. So I want the area of this triangle also. pj tjs dash. Share it total. So this triangle also I did. So let's go ahead. So if I want, so basically what we will do, we'll draw a perpendicular here. And this perpendicular will serve as the height. So if I just draw a perpendicular here, the first one and the second perpendicular will be here, or this little triangle. The green one is nothing but the altitude. So for the altitude of this blue triangle, the height, and this little one is for this little triangle, pj, So area of triangle pj, would be its half into base is what? I'll call it something better. Say this perpendicular, I will name it. So let's say A, and say this is my P. Because this is acting as the height. So if I consider the first one, pj tjs. So base is pj tj. Base will be pj into tj, and height is as. And area of triangle pj tj s dash will be again half into base is still the same. So that's pj into tj, and height is ps dash. So I need to multiply this. So area of triangle pj tjs into area of triangle pj tjs dash will be equal to 1 by 4. Then pj tj square into as into ps dash. This and then total upon pj into tj squared. So this pj tj square gets cancelled. And then now I get here simply 1 over 4, and then as into bs dash I want. So AS into BS dash is nothing but the product of perpendiculars. So product of perpendiculars drawn from foci. So product of perpendiculars drawn from foci is nothing but the drawn from foci is nothing but the square of semi-minor axis. So I'll be having half over 4 and then B square. So if I have an ellipse, then product of fruit of perpendiculars. The product of fruit of perpendiculars P1 into P2 is equal to P square. That is square of semi-minor axis. Semi-minor axis square. So B square is simply what, 12? So this would be 6 here. So if I just plug in here in this sigma, so sigma is for J is equal to 1 to N, and I have here 6. So this would be answer is equal to what? 6N. Now it depends how many triangles, how many tangents we have drawn. So whatever number of points we get, that we just need to multiply by 6 and we get the desired sum. So answer will be 6N. To the next problem. So we have just definite integration, and f and g are continuous positive functions such that f of minus x is equal to g of x minus 1. And we have f of x is equal to g of x over g of minus x. And I need this value when we are given this. So consider this guy only. So minus 20 to 20. We have here f of x over g of x dx. So when nothing works, we can simply apply King's to get here minus 20 to 20. F of minus x over g of minus x dx. Now, this could be written as integral minus 20 to 20 f of minus x. Can we get it by something of minus x if I replace here? So I'm getting here. Let's replace this one by f of, replace this one by x. So I get f of minus x is equal to g of minus x over g of x. So now we can write it down, this one here at the place of minus x. So I'll be having here g of minus x over g of x into g of minus x. Now this and this gets cancelled. F of minus x over g dash will be 1 over g of x. So I get g of x. Now I can think of adding these two equations, 1 and 2. So this gives me I is equal to integral minus 20 to 20. The base is same, so I can just add it. So f of x plus 1 over g of x dx. And now this is going to give me f of x plus 1 can be written as g of x from here. No, that is f of minus x. Okay, 1 minute, I think. This, we are getting the same equation once again because this will be nothing but g of, if I replace here by x, so I'll be having f of x is equal to g of minus x minus 1. So I get g of minus x. Okay, get it? Of minus. So we get g of x minus 1. Okay. Then we should have, instead of doing this thing, we should have done the other way. We have applied King's. Now I need to get g of minus x. If I just remove it, do I get g of minus x? Okay. So from here, I'll bring g of minus x first. So from here, g of minus x will be equal to g of x by f of x. So this means I'll be having minus 20 to 20. This will be f of minus x. Here I get g of x into f of x will be here. Now I'll add these two. So the bases are same. So 2y is equal to minus 20 to 20. F of x will be common. Then I get f of minus x plus 1. The whole upon g of x takes. Now f of minus x plus 1 will be nothing but g of x. So this gets cancelled and I get minus 20 to 20 f of x dx, which is given to me 2024. And then we have here 2i is equal to this. So I will be 1000. So the answer will be 1000. Coming to the next, we have a question. We have three complex numbers and they are unimodular, and such that this happens and this. And we have three things, Z1, Z2, Z3. So if we consider three complex numbers, say Z1, Z2, and Z3, and we are given that sum of Z1 plus Z2 plus Z3 is given to be 1, and Z1 into Z2 into Z3 is also given to be 1. So this looks like the sum of roots, and this looks like the product. So we can apply Vetta's formula and construct a polynomial Z cube minus Z1 plus Z2 plus Z3 into Z square plus minus plus, and then the dual sum Z1, Z2, Z2, Z3 plus Z1, Z3 into Z3. Yes, and then minus Z1, Z2, and Z3 is equal to 0. So this is a polynomial whose roots are Z1, Z2, Z3. So that means I'll be having Z cube minus sum of the roots is given to be 1. So this does not bother me. Plus this one I need to address carefully because we do not have this information. So Z1 and Z3, so will be Z here, and this product is given to us, that is 0. Now let's find out this thing. So consider Z1, Z2 plus Z2, Z3 plus Z1, Z3 is equal to. So I'll take Z1, Z2, Z3 common. So we can get here 1 over Z1 plus 1 over Z2 plus 1 over Z3. Because if I simplify, I get the same thing again. So this is 1. So I have here 1 over Z1 plus 1 over Z2 plus 1 over Z3. Now we need to get rid of all of these. So we'll take the help from this modulus concept. So we have here mod of Zi is equal to 1. All I is equal to 1, 2, 3. So if I square this, I get Zi into Zi bar is equal to 1. So Zi bar will be equal to 1 by Zi. So for I is equal to 1, 2, 3. So basically, this part will now be replaced by Z1 bar plus Z2 bar plus Z3 bar, which is nothing but Z1 plus Z2 plus Z3 bar. And Z1 plus Z2, Z3 is 1. So 1 bar is simply 1. That means I get the polynomial, star polynomial I'll be calling. So Z3 cube. So therefore, Z3 cube minus Z square, and this is plus only, so no point. Then minus 1 equal to 0. So we can think of factorizing. Z minus 1 is equal to 0. So this means this is Z square plus 1 into Z minus 1 is equal to 0. So Z is equal to I, comma, minus I, comma, 1. So imaginary part of Z1 is less than imaginary part of Z2 and is less than imaginary part of Z3, which means imaginary part of Z1 here is 0. This is minus 1. So Z1 I have to take as minus 1. And Z2 will be next will be 1. And Z3 will be next I, because imaginary part of Z3 is 1. This is 0. So now we need Z1 plus Z2 square plus Z3 square. No, cube. So Z1 plus Z2 square plus Z3 cube. So Z1 is minus I, Z2 square will be 1, and Z3 cube is again minus I, which gives me 1 minus 2I. So therefore its modulus will be Z1 plus Z2 plus Z3 cube will be equal to 1 minus 2I, so which is root 5. And then GIF of this thing will be 2. So the answer would be this answer equal to 2. Let's see the next one. So we now have a double sigma here and I plus j, NCI, NCJ. We want this f of n basically. So let's go ahead. So I'll call this sum as f of n is equal to this to double sigma 0 is less than or equal to I is less than j is less than or equal to n. And then I plus j into NCI plus NCJ. Since this is a restricted sum, this is a restricted sum. So we cannot think of interchanging I and J, otherwise this problem would be very simple. So what we will do, instead we will prefer writing in the reverse direction. So this I can write on n minus I plus j as n minus j. And this thing is again as n minus I plus nc n minus j. Now this is also f of n. It's only same as writing. This one will start from 1 to 10, and this one is nothing from 10 to 1. So we don't have to worry. I'll simply add these two equations. So I get 2 times f of n will be equal to the sigma. Then I is equal to n. This I gets cancelled. I get here simply 2n into nci plus ncj, because these both are same. So ncr is same as nc n minus r. We have used this. Now I keep this 2n outside. So I simply get f of n is equal to n times this double sigma nci plus ncj. And this is starting from 0 to n. Now I'll just consider this much and find out the sum. And this equation be star. So now consider dual sum of nci plus ncj, where 0 less than or equal to I is less than j is less than or equal to n. So I'll just write a matrix nc0 plus nc0, nc0 plus nc1, nc0 plus nc2. And this will go on up to nc0 plus ncn, and then nc1 plus nc0, c1 plus nc1. That means I'm just seeing all possible entries, and then we will see which one we have to take. Ncn. This would be nc2 plus nc0, nc2 plus nc1, nc2 plus nc2, so on up to nc2 plus ncn. This list would go on up to ncn plus nc0, and ncn plus nc1, ncn plus nc2, and so on up to ncn plus nc. So this is my matrix. Now if you observe carefully, so this nc0 plus nc1, this sum is same as this sum. nc0 is same as nc2 plus nc0. And if we just consider this as diagonal, suppose, and on diagonal we have I is equal to j and 0 is 2. That means here I is what, less than j, and here we have I more than j in this below diagonal. This 2 is serving as I, this is serving as j. And if we notice, so if I'll call this upper sum as u, lower sum as l, and this diagonal as d, so it is same as writing L plus U plus D is equal to total sum. And we know that L is equal to U. This, the same upper sum we have here by the symmetry. So let's find out the sum of total entries. So if you see the sum of total entries, then we need to add each and every row. So in every row, if I'm adding, I'm getting here NC0, 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 how many times? N times. So I'll find out. So I'm adding column wise. So first n plus 1 times I'm getting nc0 plus this. If I add nc0, nc1 plus nc2 and so on up to ncn, this will give me 2 power n plus. Next again I'll be having n plus 1 times nc1, and then again I get 2 power n. And this would go up to nc1 times I'll be having ncn plus 2 to the power n. That means I can take n plus 1 common. Then again I get nc0 plus nc1 plus nc2 and so on up to ncn plus n plus 1 times 2 to the power n. This will give me n plus 1 into, this is nothing but 2 to the power n plus n plus 1 into 2 to the power n. So this will be 2 to the power n plus 1 into n plus 1. This is my total sum. And now I need the diagonal. So diagonal is basically what? It's everything will be twice. So 2 times nc0 plus 2 times nc1 So this is nothing but 2 times NC0 plus NC1 plus NC2 and so on up to NCn. And this turns out to be 2 times 2 power n, which is 2 to the power n plus 1. So now I need, in the question, I need I less than j. I less than j is my upper segment. So I need u basically. So let's construct the equation. So L plus U plus D is equal to 2 to the power n plus 1 into n plus 1. Since D we have. So L plus U is equal to 2 power n plus 1 into n plus 1 minus D is 2 power n plus 1. So 2 power n plus 1, which gives me 2 power n plus 1 into n. And L and U both are same. So U will be 2 to the power n into n. This is what my sum is. That's not the this is this sum here, huh? But our intention is to find out this. So the final answer f of n would be, so therefore f of n would be n square into 2 to the power n using star. So now the next part of the question is to find n is equal to 1 to infinity n upon f of n. So sigma n is equal to 1 to infinity n upon f of n will give you what? Sigma n is equal to 1 to infinity n over f of n is n square into 2 to the power n. So this gets cancelled. So I basically get sigma n is equal to 1 to infinity 1 upon n into 2 power n. So for this thing we'll consider log series 1 minus x. So will be x plus x square by 2 plus x cubed by 3 plus x to the power 4 by 4 and so on, followed by a minus. So if I plug in x is equal to so 2 3 cubed, so 2 power 3. Okay, so we'll set x is equal to 1 by 2. So if I plug in x is equal to 1 by 2, I get log of half will be equal to minus of x will be 1 by 2 plus 1 by 2 into 2 square plus 1 by 3 into 2 cube plus 1 by 4 into 2 power 4 and so on. So this sum is only required. So which is nothing but sigma n by f of n. So n is equal to 1 to infinity, and I get here minus of ln half, which could be written as ln 2. So the final answer would be ln 2. The sum would be ln. So that's all in the session. We'll see you again in the next session. Happy learning.